Most newcomers and small-scale PC users are content with handling one application at a time. However, some people need to run several programs to handle different kinds of tasks on a regular basis. This could pose a problem if different applications had to be opened each time and one had to keep switching from one to another. Let us assume that a user is writing a report with a word processing package and decides to include some spreadsheet data in the report. With different application programs for word processing and spreadsheet functions, the user would probably have to store the document and shut down the word processing program, possibly change disks, load the spreadsheet program and data, retrieve the data with a set of program commands that bears no resemblance to those used with the word processing program, print the separate pieces from each application, and then do a cut and paste job on the report. All this because the user could not share data between separate single function packages. The solution to this was found in software integration. The effects of software integration reduce the time loss and frustration of using different applications by allowing the user to switch from one application to another while running both the applications concurrently on the same processor, allowing the data to be shared and passed on freely between these applications, providing a common interface of similar tasks with similar commands, thereby increasing ease of use. In the field of software integration, one can see three forms of software: integrated software series, integrating software shells, multifunction integrated packages. The integrated software series includes a combination of separate packages that can generally process words, manipulate spreadsheets, manage and maintain database files, create graphics, and perform data communications functions. Sometimes, other functions such as project management and outlining may also be included. Usually developed by a single supplier, all these packages are powerful, coordinated, stand-alone entities that a user can select from. They are designed to freely share data and use a common set of commands for standard tasks. Typically, a user's needs may be satisfied by just some programs in the series, and these separate programs are generally not used simultaneously. In the situation of a user continuing to use different single-function programs from different suppliers, there is the need for software that can integrate all these. This software is the integrating software shell, which acts as an integrator and manages the transfer of data between each of these separate application programs. The shell program performs its integration functions by positioning itself as a layer between the operating system and the user's application program. A multifunction integrated package typically combines most or all of the types of programs found in an integrated software series. The most commonly used ones over the years have been Microsoft's Windows, Digital Research's Graphics Environment Manager or GEM, and IBM's TopView. The multifunction integrated packages are perhaps the most comprehensive solution. They are an all-in-one package developed by a single supplier combining most or all of the single function series programs. The user gets comfortable with a common interface, similar commands, and in some cases the capability to open overlapping small windows showing the most recent task. These separate windows can be cascaded one behind the other, or they can be tiled as distinctly visible windows for clarity. Even though a multi-integrated solution may cost lesser than the separate single-function programs, the choice of using one over the other depends on whether one needs the full function capabilities of each separate application program. The need to look into the area of software packages arises because of one's need to solve a problem. All of us, at some point or another, are faced with a problem, and to handle it, we identify the problem, understand what is required to solve the problem, get convinced that the computer would be the best tool to use to handle the problem, and we understand that the best and most economical way is to pick up a ready-made software to the actual solution. For those of us who already have a PC, the software search is limited to programs that are compatible with the equipment. The process of identifying the appropriate application package depends a lot on one's ability and perseverance in studying the relevant material. These are available through various sources such as advertisements in PC magazines and mail order catalogs, software reviews in PC magazines and review booklets, live demonstrations at retail outlets, demo discs from vendors and magazines, vendor directory cum software catalogs, computer consultants, shareware programs. At this stage, one should be able to draw up a list of all the possible software choices that, in one's opinion, can be used to handle the problem. Picking the right software is a difficult task since the array of programs are quite complicated and perhaps very similar in their features. Once the broad selection list is ready, one is then ready to narrow down the field to a handful before making the final choice. This is the stage when specific queries can be addressed to see if the package features can handle them. Typically, some of the queries can be like, is the package actually available in its full function form, or is it just a pre-release version of the actual program that may get delayed? Does the output produced by the package conform to the form and content one needs? Can the package accept and process the input data in the format one needs to use it? Does the package support the acceptable range of input and output devices that one may already have or are preparing to acquire? Is the file format created by the package acceptable in terms of its size, contents, storage media, record formats, access restrictions, and degree of permanency? Is the response time of the package adequate? Is the package easy to learn and use? That is it user-friendly? Is the package equipped with good error handling checks and controls? Can the original program be duplicated and stored as a backup to protect against the loss or destruction of the original program? If the selection involves the purchase of multiple programs, can they all run on the same hardware using the same operating system? That is, are they all compatible? At the end of this stage, one should really end up with just 4 or 5 package names. The final selection can be derived by testing the package on one's own sample data and seeing if the output is satisfactory. The final screening can be done by addressing some generalized questions and some specific questions. The generalized questions cover issues such as, did the product demo satisfy one's queries with respect to format of input data, output, and compatibility with other software and hardware? Does the package have a reasonable warranty period? Do the package features and functions represent good value for money? When it comes to specific questions, it deals with issues of the specific features within the various types of applications. Let us examine some typical issues that one should consider in the various application types. Word processing programs are text manipulators that come in basic and more advanced forms of packages. One's selection of the right software will depend on issues such as frequency of handling lengthy documents versus drafts and short letters, simple formatting features versus multiple format changes, simple word processing tools versus advanced tools of spell check, mail merge, and automated functions, document orientation, continuing text versus page orientation or page-sized units. Other specific queries can include, does it support WYSIWYG? How easy are the store and retrieve operations? Is on-screen help available? The best way to analyze this is by considering one's own writing needs, gathering samples of the existing documents, and then evaluating the products based on the required output. The critical issue in selecting a DTP package is to be able to identify the type of publishing one requires. One's selection of the right software will depend on issues such as, is it for an informal family letter kind of use, or is it for a department that expects to generate income from the publication? Does the package support the page layout and format specifications one needs? Does it have an exhaustive clip art library? Does it support picture editing, that is resizing, cropping or transforming? Can it receive text data from other programs, such as the word processing program? Is it compatible with other input-output devices, such as scanners and color printers? Again here, the best way to analyze would be to take a draft of the output and see if the software features address the output requirements. The data communication packages allow the transfer of data over a communication line. One's choice of the perfect data communication package would depend on issues such as, does one need a simple PC-to-PC kind of communication package or a multi-purpose package to communicate with other PCs, public bulletin boards, and public information retrieval services? Does one need a customized package that is tuned to a specific information retrieval service, or does one need a more powerful one that can search through a number of services? Can it download data directly into one's other application program files, spreadsheets, databases, etc.? Like word processing packages, spreadsheet packages also come in the basic and advanced varieties. One's choice of the most appropriate spreadsheet program will depend on issues such as, does one need a simple spreadsheet or a powerful one that integrates graphics, macros and other functions? Does it handle one worksheet at a time, or does it allow you to open many worksheets? Is it easy to set up the spreadsheet with entries, labels and formulae? Is it easy to move, edit and format cell content? Does it support pre-designed templates? Does it allow resized page layouts for condensed printing? Is it fast in calculations and easy to use? One's choice of a suitable investment analysis package will depend greatly on whether one opts for the fundamental analysis approach, the technical analysis approach, or the personal financial management approach. Under the fundamental analysis approach, the package needs to tap online databases. Here, the issues of concern would include, how many companies and industries can the package screen? Can one program it to combine items for screening? Does it allow customized report formats in addition to pre-designed formats? If the technical analysis approach is chosen, then one needs to consider the following issues. Does the package support computations, charts and plots? Does the portfolio management module in the package handle the kind of securities one deals with? Can it automatically update the holdings with data accessed from online retrieval systems? Can one get customized report format? If one wants an investment analysis package for personal financial management, one needs to look into the following issues. Can the package handle a wide range of accounts? Does it have features to capture the tax-sensitive information? Does it manage one's current and expected cash flows? Can it maintain and project one's income and expenditure? The accounting package is used for various accounting purposes. One's choice of a particular package will depend on whether the package is able to fit in with the current system, provide a user interface that conforms with the current accounting entry methods, trap errors suitably with appropriate checks and controls, perform reliably and fast, expand and grow as the business grows. Other considerations may include vendor support for upgrades, documentation, and warranty. Statistical packages should all be able to process masses of numeric data. So the main considerations in selecting a package here will be those of speed and accuracy of results. One may also like to review the kind of computation formulae and functions available in each of the packages. Some packages are able to use the special math coprocessor chips to increase the speed of calculation. The choice of a graphics package will depend on whether one needs it for designing, painting, analysis or presentations. Here, the considerations can be varied and include whether the software supports adequate input and output devices, scanners, light pen, drawing tablets, laser printers, plotters, etc. Does it have an extensive clip art library or built-in chart functions? Can it receive data from other applications you use? Can it provide varied coloring tools, editing, scaling and printing features? Can it create a timed slideshow with sound and narration effects? It would be best to take an output draft and see which package best fits the requirement. While selecting a database management package, one needs to identify first whether one really needs a DBMS or whether a simple file management package will suffice. If one wants a full-function DBMS, then the areas of concern would be: is the DBMS able to work with records from more than one file at a time? Does it support an easy-to-use file maintenance system for adding, modifying and deleting records? Does it easily handle sorting, searching and merging requirements? Does it support arithmetic operations? Does it support automatic updation? Does it have a report generator? If, in one's area of work, the database structures are likely to be changed frequently, it would be better to opt for a relational DBMS solution. Project management software come in different forms. Some are simple project mappers that help you track the progress of the project as each day passes. If, however, it is important to compare planned versus actual project details in terms of time, cost, resources, etc., it is important that you ensure that the package can handle this requirement. Other considerations would include: can the package handle codes for project entities? How many project tasks can be defined and how many resources per task can be assigned? What kind of printed reports does the package support? Memory resident packages are items one may want to add onto one's system for increasing the ease of use. In selecting these, one would need to consider the following issues. Is the package compatible with the primary applications running on the system, or does it conflict with any? Does one have to increase the RAM or primary memory capacity to accommodate it? Is it possible to upgrade the primary memory in the system? Here, it is necessary that the package be tested on the system with the other applications before buying it. You are now familiar with the general guidelines while selecting application packages in each of the common activity areas. With the ultimate choice in hand, one can then place one's order for the package from the producer, the retail store, or via mail order. At this stage, one may come across other factors making one opt for a seemingly more expensive choice vis-a-vis the hidden advantages and plus points. These may include factors of after-sales support, annual maintenance and upgrades, support from where, that is local or outstation, freebies and buyer incentives, discounts and relaxed payment schemes. Whatever be the choice, in the end, one should be convinced that the package addresses one's need and is the best value for money. The multitude of application programs we have reviewed and analyzed cannot run on any system without system software. As you may recall, system software comprises all those programs and routines that are integral to the basic functioning of the computer system. Let us take a look at the conceptual diagram of the user and the machine and see where the system software layer is located. As you can see, it acts as an interface between all the user-based programs and languages and the hardware core. In a sense, system software isolates the user from technicalities of the hardware functioning. System software comprises the operating system and other support utilities. An operating system, or OS as it is called, is an integrated set of intricate and complex programs that manage the resources and overall operations of a computer. Although the functions available are most important, they are transparent or invisible to the user. Every computer, irrespective of size and capability, must have an operating system. In fact, the OS is the first software to be loaded into a new computer, which then handles the loading of other application programs or languages. The OS lets the computer manage its own operations by automatically calling in the required application program, translating any other special service programs, and managing the retrieval and storage of data needed to produce the output desired by users. All operating systems today are made up of numerous program modules that handle memory management, processor management, device management, and information management. These functions are handled by basically two categories of OS programs: control programs and processing programs. One of the functions of the OS is to control input-output housekeeping operations. It monitors the flow of data from the input devices, keyboard, mouse, joystick, scanners, and other input devices, to the processor, as well as from the processor to the output devices, such as monitors and printers. It also controls the data movement between the primary and secondary storage units found in the PC system. The overall management of the computer system is controlled by a master program called OS Supervisor or Monitor or Kernel. The OS Supervisor resides in the primary storage section of the processor and coordinates all the other programs of the OS. These other secondary programs are maintained on an online system residence device so that they can be retrieved or called in by the supervisor and read into the RAM whenever necessary. As one task is completed, the system control always branches back to the supervisor, who then directs the completion of the next task in sequence. We have seen how the operating system manages overall supervision. It is the OS that provides the linkages between specific jobs or tasks during the processing of applications. The specific tasks are handled by job control programs, which are usually coded in a job control language by specialized programmers and are stored on system residence devices. The need for such programs is more important in the field of large-scale batch processing, where the job control programs give the OS the details about the job name, username, account, input-output devices used, and which software is to be used if a language translation is necessary. When the processing is completed, the OS supervisor again takes charge and then sends a signal to the OS residence device to load the job control program into the processor. You are already aware that the speed of input-output devices is much slower than the processor's speed. Since processors can process far more data in a second than a single set of input-output devices could supply or receive, it is common to overlap input-output and processing jobs. The time allocated to the processor to handle a particular task is called a time slice. 2 or 3 time slices may be required for a particular job to be completed. This apportion of time slices is what is the key in multi-programming, multitasking, and concurrent programming systems. In such systems, the processor executes one portion of one program, then a portion of another program, and so on, performing the switches between programs almost instantly. Another term worth getting familiarized with at this point is multiprocessing. It refers to the processing approach in which there are 2 or more independent processors linked together in a coordinated manner. In such a system, tasks from separate independent programs or different instructions from the same program are processed simultaneously by the different processors. It is the duty of the OS to schedule and coordinate the input-output processing functions of all these systems. To enable all these intricate and complex functions, the OS has the added responsibility of being able to perform system scheduling tasks, handle system interruptions, and monitor system status and supply appropriate messages to people. System scheduling becomes necessary since multiple tasks are performed to balance input-output and processing requirements. Since this causes an overlapping of input-output and processing operations, the OS uses channels to balance these multitasking capabilities. Channels are a combination of hardware and software controls that manage and provide the path or route for data to be transferred between slower input-output devices and the fast processor. The speed of these transfers is further enhanced with special buffers. Input buffers are capable of slow-speed input from the input devices and high-speed output to the processor. Output buffers allow very fast input from the processor and slow output to match output devices. The operating system also handles system interrupts. System or program interrupts take place when programs with different priorities clash for processor time. In multi-programming systems, priority is assigned to each program. High priority is assigned to programs handling interactive or quick response tasks, while low priority is assigned to programs that handle batch processing or non-interactive tasks. Typically, a high priority program will interrupt the processing of a low priority program, resulting in a program interrupt. The OS takes over and manages the system during such a system interrupt by ensuring that the data, instructions, and intermediate processing results of the interrupted program are kept separate from any other job, reserving appropriate storage partitions, and resuming the interrupted program's operations exactly as it was going on after the high priority program task is over. The OS also constantly monitors system status during processing operations. It responds to user calls for help, sends messages if an input or output device is not responding, switches control to programs in queue, etc. In larger systems, the OS also maintains a system log in terms of the time, duration, and signatures against each job process. It can also monitor system security in terms of authorizing access and sending necessary warnings for attempts at unauthorized access from workstations. An important feature of the OS is its program call-up capability. With this, the OS is able to call in the required secondary programs from the system residence device into the primary storage when necessary. This gives it access to a number of programs that can simplify processing operations. The OS-controlled processing programs are of three types: translating programs, utility programs, and library programs. Translation programs or translators convert the program written in human intelligible languages into machine language codes for the computer to process. Translators are loaded into the RAM where they control the translation process. Utility programs are those special routines which the OS calls up when sorting, merging, or data transfer tasks need to be performed. Here, the OS is directed by the job control program instructions about which utility program is necessary. Library programs are a series of frequently used subroutines stored in a library. These tested library programs are stored in a machine language form and called in by the OS whenever necessary. A special program called the librarian program controls the storage and use of the program in the system library. It also maintains a library program directory and monitors the addition and deletion of routines from the library. As the user or a potential user of a personal computer, you can appreciate the importance of the operating system. It is only after an OS is loaded into a PC can the user communicate with it, supply application programs designed to run with a particular OS, furnish input data, and receive output results. Having understood the role, functions, and uses of the operating system, it is time now to get familiar with some of the popular OSs of our time. In the earlier days, proprietary operating systems were developed that could run on a single make of a machine. Since the application program must run in harmony with the OS, software written for that OS remained restricted to that brand of machines and OS. This resulted in thousands of similar application programs being written only because one program for a particular OS could not be run on another OS. The evolution of operating systems led to the development of general operating systems which were not machine dependent. Rather, they paved the way for application programs supplied by scores of different manufacturers to run on any machine that had the general OS. There are many such operating systems, and the evaluation of any is based on the microprocessor it worked with, the processor word size, and its compatibility with other systems. Developed in the early 1970s by Digital Research, the CPM80 operating system was one of the most popular OSs of our time. The name CPM refers to Control Program for Microprocessor, and the 80 refers to the microprocessor model. Due to its widespread acceptance, CPM80 became a de facto, unofficial industry-recognized OS standard for 8-bit systems using Z80 and 8080 microprocessors. Hordes of independent software suppliers wrote 8-bit software that were compatible with CPM80. This wealth of available software forced the developers of later 8-bit machines to make the OS available to their customers. Plug-in hardware kits were also developed to allow users of Apple and Radio Shack machines to run software written for the CPM80. Later, a higher version of the OS, called CPM86, was developed to run on 16-bit machines. With the evolution of hardware and software, most software programs were being written for 16 and 32-bit models. The next dominant operating system whose widespread acceptance had made it the de facto standard is MS-DOS, developed by Microsoft Corporation. MS-DOS, or Microsoft Disk Operating System, became very popular because it was the OS selected by the hardware giant IBM to use with its earlier PCs. After IBM, nearly 50 other manufacturers have adopted MS-DOS as the OS for their computer systems. MS-DOS was further revised for the multitasking environment in the form of MS-OS2, which was packaged with IBM's PS2 multitasking system. Most of the new business and professional software prepared by independent suppliers is first written for MS-DOS and OS2 and then developed for other OS environments. The latest buzzword in operating system environment is Windows. Unlike the earlier OSs, which were prompt-based, Windows is based on a graphical user interface, or GUI, and uses icons and visual menus. Being graphics-based, it uses a mouse in addition to the keyboard for receiving user input. It can be loaded on any IBM-compatible machine and run the hordes of software currently available for Windows-based systems. While Windows systems up to the version of Windows 3.x needed the MS-DOS OS to ride on, later versions of Windows, such as Windows 95 and higher, were independent operating systems. Today, almost every desktop PC in the user community can be seen to be using the Windows operating system. A very powerful OS called Unix was first developed for larger machines at Bell Laboratories in 1969. It was later adapted for PC systems, as well as its recent acceptance has turned it into another de facto standard. The Unix OS is multi-user, multitasking system that is used with many powerful 16 and 32-bit PCs. It has very sophisticated features, is very fast, flexible, and very high on security. In fact, much of the Internet and www operations run on the Unix system, which, with software adaptations, run with any other OS so comfortably that it is not apparent to the user. The P system developed at the University of California is yet another 16-bit operating system.